an ideal op-amp circuit. Let's say we have an ideal op-amp circuit given like this. We have an op-amp, and this is minus terminal, plus terminal. We have output, and let's say the resistance here is 1000 ohm resistance, and this one is connected with 200 ohm resistance, and here we have the V out, and let's say 20 or 20 voltage input right here, and this one is connected to the ground. What's the V output here? How can we calculate the V output? Now, when we are dealing with ideal op-amp, we know that current flow in and out is always 0, because we assume this assume the resistance inside of the ideal op-amp to be infinity, so there's no current flow inside or outside, and V plus is equal to V minus. This is the two conditions that you have to follow. So V plus is equal to V minus, and V plus I can easily find because this is connected to the ground, so V plus is 0, therefore V minus also 0. Okay, now let's apply KCL right here at this node. If I apply KCL at this node, since this is also 0, the voltage here is going to be 0 voltage. So if I take the current to be this side, let's call this one I1, and let's say this is I2, and whatever the current flows in this node should be the current exiting this node, but according to the KCL. KCL says summation of current in is equal to summation of current out. So I1 must be equal to I2 because there's no current flow in the input of the op-amp. So this is going to be I1 is equal to I2. And if I write this one, because here we have two unknown variables, so to make this one easier, we can solve this one in terms of voltage. Here the voltage is plus, you can see the plus sign is on top, so this voltage is going to be plus 20 voltage. So 20 minus 0 divided by 1000 is equivalent to I1. So instead of I1, I replace that one with this, and then I2 is going to be what? Since the current is going in this direction, this voltage minus this voltage divided by the resistance in between. 0 minus V out, 0 minus V out divided by the resistance in between, that is 200. So here we just want to find out what is V out voltages. So we just try to rearrange this equation and find the final value. That's going to be 20 over 1000 multiplied by 200, and this is still negative VO, and then this is, okay, wait a minute, we keep this one as it is, 20, and this one is going to be 1 over 5, and then 20 divided by 5, that's equal to 4. So negative VO is equal to 4, therefore VO is equal to negative 4. So the voltage right here is negative 4 voltage. Okay, this is one thing. Let's say if you have a question, we found out the V out voltage. Okay, let's say we have a question, turn this one into a positive voltage. How can you do that? If you want to turn this voltage into a positive voltage, what you can do is you can connect another op-amp circuit like this. If you connect another op-amp circuit with this, and wait a minute, okay, let's connect another op-amp circuit with this, and we connect this one to the ground and this one to be, let's put some value, let's say 500, and then you have to put the equal value here, 500. If you put the equal value here and here, and the voltage here, this is new voltage output. When you do that, let's see what happens. So this is minus voltage, right? So what is this? Let's apply KCL again. Let's take this node and apply KCL. I'm going to erase all these things. Okay, let's apply the KCL. KCL says summation of current in is equal to summation of current out. Summation of current in is equal to summation of current out. Let's call this current going through this is as Ix. Let's call the current going through this as Iy. If I do that, then this is this Ix must be equal to Iy because there's no current flow inside or outside of the terminal in the op-amp circuit. So these two are going to be the current through this is 0, this is 0, then this Ix must be equal to Iy because that's the only output we have from this node according to KCL. So we put Ix is equal to Iy, and we know this voltage, and this is 0 voltage because you can see this plus terminal is connected to the ground. So in our op-amp circuit, whatever the plus terminal voltage is going to be equal to whatever the voltage we have in the minus terminal as well. So if V plus is equal to 0, then V minus also equal to 0. So this voltage here is 0 voltage. Then if I write the equation for current in terms of voltage, this is going to be minus 4 voltage minus 0 divided by the resistance in between, that's 500. And then here we have 0 and the VO, that's what we are interested in. So 0 minus VO divided by the resistance in between, that's 500. Now here we are trying to solve for the VO. This is minus 4 divided by 500 and this is minus VO divided by 500. We can cancel these two negatives and this 500 cancels each other. We get VO is to be equal to positive 4. That's how we can change a negative voltage into a positive voltage using another op-amp. Now when you're doing that, you have to make sure you are having these two resistance equal value. If you have a different value, the output value is going to change. That's all you have to know. That's it for this video, guys. Thanks for watching. See you guys on my next video.